Good morning, everybody. Mr. Jamnik here. As we continue with Module 11, and we're working on the I can statement. So, I can model and solve using multiplication and division. So, this is the second part of what we've been doing, and the first part, which we did, was adding and subtracting equations and using the inverse, which is the opposite. You're doing the same exact process now, except we're doing it for multiplication and division. So just like we did before, I'm going to put up inverse to make sure everyone knows that that means the opposite. And then we're going to work through the steps and understand why we're doing one to the other and how we're coming to an answer, and we're showing our work and we're showing the process. And then we're going to work to the HOT, the higher order thinking questions, using the modeling and the solving of multiplication and division. So when we're looking at this, we're thinking about, again, the inverse. So with the I can statement, that's what you guys need to focus on too. Just like when we do the I do, we do, you do, how we're breaking it down. So I'm doing this part, and as you guys are thinking about that, that's when I always upload your student book with the guided practice, the your turns, independent, HOT. This is all stuff for you guys to work on during the week, just like we do if you're in class. So you guys understand the whole process remains the same for us. So with the inverse and the opposite. So if I gave you x divided by 2 equals 10. Now with multiplication and division, a lot of times people think it's easier because the process is a lot more simpler when you have to do one side and you have to do to the other with the inverse. A lot of people know mental math a lot easier than maybe showing the process of addition and subtraction. But you still have to justify and show what you're doing and why. Again, these answers can jump out to you. You should know what it is right away. But just to show you what you're doing to make sure that it understands the correct process of the answer. So if this one says x divided by 2 equals 10. So we know with the inverse, again, we're looking at the opposite. So I know automatically what is the opposite of division. So just like when you go back to the I can statement, the opposite of division is multiplication. So if I know, just to show you, I'm going to put this here, which is opposite means multiply. Okay? So all you're doing is taking the two numbers that you see. So what's the two numbers you see? The denominator is the 2, and the answer is the 10. So if you're doing the inverse of division, you're just taking the two numbers that you see. You can only take those two numbers. You can't just take another number that doesn't appear there. So you're taking the denominator that you're going to be given, and you're always going to take the answer you're always going to be given, and you take those two and you multiply it, and that's going to give you what the variable x is going to be. So very simple. So what is 2 times 10? Everyone should get an answer of what? Right? 20. So if I take out, so just like we were doing before, just to show you, I'm going to keep this here. If I do 20 divided by 2 equals 10. Then if I looked at this, then you should know if this is a true statement or not. Is 20 divided by 2 equal 10? Yes, absolutely. So this is basically the process that you're showing. You're taking the variable that's given to you, you're taking the operation, which is division, by the denominator, equaling the answer. So you're doing the opposite of division, the inverse. Always keep that word in your mind. Inverse, inverse, inverse. Opposite, opposite, and opposite. So x divided by 2 equals 10. We do the inverse of division, which is multiplication. So we take denominator times the whole number answer, and we get 20. And then just to rewrite it so you can show exactly what you're doing that understands the process, we're replacing the 20 now as our numerator. So now we have numerator of 20 divided by the denominator of 2 gives us an answer of 10. So we know that we did it from start to finish. This is the process that you're doing to model and to solve using multiplication and division. You can use cubes, just like when you use different manipulatives in class, you could think about all these different things that we could do. We used to use those chips, the red and yellow. There's tons of things you can do. Think about stuff you have laying around the house that you could show how to do multiplication or division. There's a lot of great stuff you can use. You just got to think about how that applies to the answer, and then use that accordingly to what you can use. For my daughter, for instance, when she does this work, she likes to draw. She has the different Q, and we know that 10, 10, 10. This one is 10, 10, 10. So there's different multiple ways you could show it just to show what you're doing to see that the statement is true. And that's entirely up to you. But again, you have to just show and prove what the inverse is of the actual operation that you're doing. Okay, so let's take a look at another one. What do we got here? Okay, so another one. Let's go to, what are we going to do? We'll do 8x equals, sorry guys, let's take that off. Let's do 5x equals 25. Okay, so now take a look at this one. Again, you're only focusing on that can, which is model and solve multiplication and division. So going back to what we discussed throughout order of operations and equations and expressions, okay, when you see a number next to a variable, you know that should be what? Right? So number next to a variable means that you multiply. So just like we did for the first one, we had a line that means division. We do the inverse, which is multiplication. Now we're doing the other part. So 5x equals 25. So again, showing the process and the steps that's justifying how you're telling me what x equals. And you have to get that by itself, right? So 5x equals 25. If I know a number next to a variable means that I multiply, the opposite of multiplication is going to be division. So let me just take this out. So I can draw the line here and draw the line there. Don't forget, what you do to one side, you have to do to the other side. This is going to give you the final answer, and this is going to tell you what the actual variable is going to be by itself. So 5x equals 25. I know the 5 is next to the variable, so that's what I'm focusing on. This is a 5, and what I do to one side, I do to the other, and then this becomes a 5. Just like you did, it's the same kind of thought process. These 5s cancel out. Now you have the variable x by itself. And then we take a look, and we get 25 divided by 5, and you guys should know mental math, you're thinking of it, would equal 5, okay? And just another way when you're working on this, how can you think, how can I just check real quick just to make sure, and then just jumping the gun. If you take 5 times 5, you should get what? 25. It's just a quick little, we used to do the flashcard game to, hold up and see what it equals, if it's addition, subtraction, multiplication, division. So it's just a simple thing, just kind of work backwards to what you're doing. But 5x equals 25. Number next to variable is multiplication. So you do the inverse, which is divide. Divide both sides by the number next to the variable. The numbers cancel out. You now have the variable by itself. And then 25 divided by 5 is 5. And that's what you're doing to solve the process. Okay? Let's do 2 more. What do we got here? Next one we're going to do, let's do x over 8 equals 2. Okay? Same thing. I'm looking at the problem. So if I ask you to please show me your work and then, explain what you did, this is what you're going to have to do. You can look at this real quick and you can know the answer top of your head. That's great. You should know what it is. But the main thing is when you're asking to show what you do to get that answer, this is where people, make sure that the process understands. So I know we have the variable, division sign, we have the whole number equals 2. My main focus is that I need to get this answer up top. I need to find the numerator that when I divide it by the denominator, it's going to give me the answer of 2, right? So now I know that the opposite of division is multiplication. So I can just put here, times 2. Times the whole number and the denominator. So the opposite, but a lot of people get confused sometimes to put an x here. So don't forget, you can also put the dot, which represents multiplication. It's a lot easier, especially if you have a variable that's the same letter that looks like the operation. It can get confusing. So the variable is x. You have the division sign, which is divide. You got the denominator is 8 and the answer of 2. Okay, we're doing the inverse of division, which is multiplication. So you're really having, what is 8 times 2? Very simple. It's 16. So we're going to rewrite it. 16 is now our numerator. 8 we have as our denominator equals 2. So if we take a look back and we can see, did we do the process right? You have to explain. Yeah, okay. I know 16 divided by 8 equals 2. Very simple. You just showed what you're doing from one side to the other, and then how the numerator now can be divided by the denominator to give us an answer. And then again, just retracing it. Does 8 times 2 equal 16? Absolutely. This is how you're showing what you're doing from the inverse to one side to the other. And then eventually you're going to apply this to, like we've been doing, the open-ended or the HOT, higher order thinking questions, which really, again, that's why we're using what we did for the problem of the day. Okay, so we're going to do one more. We got here. Okay, last one for you guys. We got 4x equals 16. Okay, 4x equals 16. So, we're looking at it. We're taking our time. We're thinking about the I can statement. We're using multiplication and division. You guys know that a number next to a variable is multiply. So the opposite of multiplication is division. So we do divide by 4. And what we do to one side, we do to the other. So we divide by 4. Once we do that, we know that the 4's can cancel each other out. We have the x, which is the variable, is now by itself, equals, and now again, we went from the inverse of multiplication to division. So what is 16 divided by 4? And the answer is 4, right? So going back, retrace, we got 4 times 4, which should give us what? 16. So when you guys are doing multiplication and division, you're thinking about the same process that we're doing. You're taking the I can with the, I do, we do, you do, and thinking about how I'm applying that, and if this is not enough and you're thinking about it, I told you, always think about using cubes, diagrams, writing the vocabulary down, using the math terms, always keeping this down. Inverse, opposite, inverse, opposite. Think about that, because once you see the problem, something should trigger saying, all right, well, I know that's division, but we're focusing on now for this module is that we're doing the inverse of what we need to do. So if you want immediately, you can look at it and say, all right, that's division, that's multiplication, but I know up here I could put, we're going to have to divide. Just to show you, to retrace your steps to what you're doing. So this is the process for the second part when we're modeling and using multiplication and division. So keep using these videos and the guided practice and the independent practice, and then most importantly the HOT, because I'm going to go over one of those higher order thinking questions and how you take out the words and the terms, and then what you need to do to justify if you're thinking you're dividing first and then getting an answer, or you're multiplying first and then get an answer. Because don't forget, the whole basic of these HOT questions and open-ended are, it's going to ask you to solve a problem, but it has to be the inverse of what you're doing. So you're taking the problem and making sure that the answer itself makes sense to the problem that you're completing. And I'll work through that when we do the next part. Okay, so again, use this. Keep up the great work, and look out for the next video where I'm going to show you guys how to model and explain an open-ended question doing multiplication and division. Everybody have a great day.